Okay, our objective today is to, what does it say? Identify and apply dimension change of 3D figures. So what you're going to get right now is a notes sheet with an assignment on the back. This is going to be short and sweet. Now, we should have done this on the test that y'all took Friday and today, but I pushed it back so we wouldn't do the test during a test week, even though some were finishing today. Bottom line is, we're going to do this. It's going to be short and sweet. Okay, the assignment's on the back. It's 4 multiple choice questions. It's not a big deal. But if you're still finishing a test today, you need to do that first. You can do this later because it's not a big deal. But you got to finish that test. Okay, so I see a couple people with a test in front of them doing things they shouldn't do. So let's go ahead and do our tests. Right? Okay, so also make sure you've turned in the Mario assignment, missing work. You know your grade now. And if you got missing work, turn it in. Some of our grades keep going up and down, and we're like, what the heck? Well, that's because once you finally turn in all your late work, then all the stuff you've been not doing gets put in, and you get behind again. So again, every volume assignment, 4 of them. Look up here at the front. Cylinders and cones, prisms and pyramids, spheres, and Mario. They're all put in the gradebook now. So make sure you turn those in. All right, enough of that. Let's talk about... where are we at? Volume change of dimensions. Now this should look very familiar. Do y'all remember last test on surface area we did change of dimension from 1D to 2D? Remember talking about that? Or whether you remember or not, look up here, okay? Let's talk about how many dimensions there are, okay? So if I'm talking about length, width, height, or if I see the word dimensions, how many dimensions is that? What? 1. 1 dimension, okay? Everyone's paying attention, right? So let's put 1D off to the side here, 1-dimensional. If we see the phrase area or surface area, that's how many dimensions? Okay, 2-dimensional, right? Both of those were old news. We did an assignment on that last unit. But here we are at volume. Take a wild guess. How many dimensions is that? 3D, okay? And it kind of makes sense because our units are squared for area and our units are cubed for 3-dimensional volume, right? So let's read this. It says, if the lengths/dimensions, if the 1D change of a 3D solid is multiplied by a scale factor, then the surface area of the same 3D solid is multiplied by the same scale factor squared. Okay, ignore the grammatical errors there, sorry. But remember, from 1D to 2D, the change, the scale factor, is going to be squared. That's old news. Bless you. But today, something new. 3-dimensional volume, right? If the lengths/dimensions, which are 1-dimensional, of a 3D solid are multiplied by a scale factor, and remember, the scale factor is K, right? Whatever K is, then the volume, right, which is 3D, surface area was 2D, then the volume of the same 3D solid multiplied by the same scale factor, what? So, what do you think? If I go from 1D to 3D, what's happening to my scale factor? Instead of squared, it's going to be cubed, okay? 3rd power because it's 3D. Cubed. Cube with the D. Okay? So we're going to have 2 possibilities. If we go to surface area, you square it. If we go to volume, you cube it. That's it. Okay? We're not even going to do the working backwards. We're just going to keep it simple. Okay? So, example 1. Let's try this. The dimensions, meaning how many dimensions is the phrase dimensions? Up here, right here, 1D, right? So we know dimensions means 1D. If the 1D change of a triangular prism, it says it's multiplied by a half. That's my K, right? What is the effect on the surface area, 2D, and the volume, 3D? They want to know what are the 2 changes you're going to have in the surface area and the volume. We learned surface area. Now we're learning volume. It's one little thing different. But it is easy, hopefully. So let's try this out. If you remember last time we did this, we would write 1D underneath it times what? So what was my K? What was my scale factor? 1/2. So the one-dimensional change is times 1/2. So you tell me, how do I get the two-dimensional change? What do I do to 1/2? 2D means second power. I'm going to square it, okay? So the 1/2 is going to be squared. What is 1/2 squared? We could type it in our calculators, even if we got the old ones. If we do 1/2 squared, okay, we would get 1/2 squared gives me 0.25. Here's a little trick. If you press math, enter, enter, it'll tell you what the fraction is, and it is 1/4. Okay, so let's make this smaller. Okay, so we get 1/4. Cool. But I'm also looking for the volume, the 3D change. So guess what? We're going to write a 3D over here. All right. So I'll do this in blue. Here's the new stuff for today, in blue. To go from 1D to 3D, it's not going to be 1/2 squared. It's going to be 1/2 what? Cubed, right? So times 1/2 cubed. Let's try that in our calculator. So I'm going to do parentheses 1 divided by 2, caret 3. I hit enter, I get a fraction, I get a decimal, and then I press math, enter, enter. Might be kind of hard to see, but I get 1/8. Okay? Those are my two answers. 1/8 for the volume, and 1/4 for the surface area. All right? So again, if I could boil this down, really simplify it, whatever the change is, you square it for surface areas change, and you cube it for volumes change in scale factor. Try example 2. Same thing, different number, right? What happened to the surface area and volume of a rectangular pyramid if the dimensions, which are 1D, are quadrupled? Okay? That's my K, my change. So once again, let's start with 1D. What does quadruple mean? Times 4. Very good. So for 2D, it's going to be 4 what? Squared. What is 4 squared? Hopefully we know 4 times 4, or type it in your calculator, 4 squared. Okay. So my surface area change, this one right here, is times 16. Cool. But I also need to find the change in the volume. So 3D change. It's times 4 to the what power? Cubed, so third power, right? So you could, in your calculator, do 4 caret 3. Everyone hear me. 4 cubed is not 12. Okay, cubed does not mean times 3. Otherwise, we just do times 3, right? 4 cubed means 4 times 4 times 4, right? So I would definitely use my calculator for cubing. So 4 times 4 times 4. 4 cubed is, okay, 4 caret 3. Hit enter, I get 64. Yes, okay. So my volume change was 64. My surface area change was 16. Those are my two answers, right? So just read the problem. If it says surface area, squared. If it says volume, cubed, you can do it. Last one. This is the only way it might be different, is if it gives you a volume, okay? So if it gives you a volume, the last step is just to multiply them. So check it out. Example 3. If the volume of a cube is 125 cubic inches, dimensions are increased by a factor of 4. That means 1D times 4. I'm looking for a new volume, which is 3D. See, I don't need 2D. I'm going from dimensions to volume. Okay? Now this is the same number as the last problem, right? So 4 cubed is 64, right? It's kind of like the same problem, except it asks us, what is the new volume? So I need to take my old volume, okay? Old volume is 125, and I need to use my multiplier, 64. 125 times 64. What is 125 times 64? 8,000. Okay? And my units would be inches cubed because it's volume. Okay? So does everyone see how sometimes you have to multiply to get your final answer? Okay? So if you take the assignment, flip it over, or sorry, you take those notes, you flip it over, you get the assignment. It is 4 multiple choice problems, okay? So, you can do this, right? Here's your assignment, 4 multiple choice. Keeping it super simple. It's something you could finish right now and turn it in, get an easy 100, okay? Don't waste your time when you could get an easy 100, because missing grades piling up, that's how our grades go down, okay? So let's knock it out now. Easy stuff, right?